Welcome to the SIG Auth deep dive session. My name is Tim Allclair. I'm one of the co-chairs of SIG Auth. And we thought you might all be a little tired of hearing about solutions and new features that are going to solve all your problems. So we thought we'd just offer you some problems without solutions. And so the first one of these I want to talk about is add-on auth, authentication and authorization. There's a lot of different features that are going to be run on the cluster to add functionality to the cluster. As a few examples, local volume provisioning runs daemon sets on nodes and has a central control plane component. Similarly, device plugins and device metrics also have node-level plugins, CRI streaming server, and then there's a bunch of cluster-level add-ons as well. And so the cluster-level add-ons is mostly solved. So for instance, you have a controller running somewhere in the cluster. To talk to the API server, it's going to authenticate the server with the cluster CA that gets auto-mounted alongside the service account token. The client authentication is done through service accounts, and authorization typically done through RBAC, but any other authorizer would work as well. Once the controller needs to talk to node-level daemon set components, it gets a little more complicated. We don't currently have a solution for the controller to validate that it's talking to the right daemon set pod. One solution we've kind of discussed is having an auto approval flow along with auto approval of certificate signing requests, along with per pod identity with enhanced service accounts. This could let us have an in-cluster special certificate that is kind of tied to that pod, and by kind of embedding the pod UID and other pod data into the certificate data. This would require a custom TLS validation flow. And so kind of custom client code, but again, would work for the controller. One other thing to mention here is this is sort of a problem that is solved by the service meshes. But because these are add-ons that we expect to run in most or maybe all, in some cases, Kubernetes clusters, we can't depend on service meshes to solve this for us. Client authentication in this case is basically solved through service count tokens and the token review API, especially with the enhancements. Adding audiences to those tokens means that the token can be dedicated to that specific request. And then authorization, similarly, RBAC plus subject access review. So now going in the other direction, the authentication here is mostly solved, again, using the cluster CA to validate the server, service accounts with per pod identity for the daemon set pods. And then for the authorization piece, we've discussed maybe using the node authorizer and extending that to apply to daemon sets by checking where that pod is running. Again, sort of an open question how to do this. And then finally, for the daemon sets to talk to the controller, so again, we have this kind of auto approval flow for certs potentially, but here we probably don't want a per pod certificate. We would want a service certificate. So trying to figure out some way of auto approving that with the service count identity. Client authentication is mostly solved with per pod identity and token review. And then authorization, if we did the node authorizer applied to the daemon sets, then it would also work with subject access review. And one thing to note about this is we don't necessarily need to solve both this case and this case. It's just kind of a pull versus a push model, and so we can often just flip the direction of information flow around. So the next problem we wanted to talk to you about is pod admission and policy. We have a bunch of built-in policy controllers in Kubernetes. We have pod security policy, network policy, image policy, a bunch of others. They all work kind of slightly differently, especially when in the way that we bind the policy to decide whether this policy should be applied to this request. So for pod security policy, we check it against the creating, in kind of the naive approach is to say, does this user have permission to do this request? The problem is users typically don't create pods, they create deployments or replica sets. And so to get around that, we also check whether the pod's service account is authorized to use that policy, which is sort of counterintuitive. Network policy is namespaced, and then a pod selector determines which pods it is applied to. Image policy is delegated entirely to a webhook, and the review request itself includes the image, annotations, and namespace, so it's kind of up to the webhook to decide what to do with that. Limit ranger and resource quota are basically namespaced singletons, but Kubernetes doesn't really support singleton resources, so this is kind of strange. And toleration and node selector are also namespace singletons, but this time just attached to the namespace object. So there's kind of a few patterns that fall out of here. The first is just apply policy at the namespace level. This is my favorite. It's consistent with authorization because when you create an object, the permission is checked against the namespace. Like, do you have create permission in the namespace? But it can't really be applied more granularly, although I think we should also include label selectors, personally. The second one is basically the pod security policy approach, which we already talked about. It's counterintuitive. It's not really any more secure than just applying it at the namespace level because unless you have a second policy mechanism to limit service accounts, then you're just still checking permission at the namespace level. And pod security policy, I'll mention also because it conflates this with also checking the user, it actually ends up with weaker security. So for instance, if you want to run a privileged pod that needs to create other pods in other namespaces, that means that any pod that privileged pod creates is also going to be able to be privileged potentially, since you have to have a privileged pod security policy to run that privileged pod in the first place. And then the last approach is sort of the one that kind of seems the most natural at first. It's does the user have permission to create this object? And so check the policy on the creation of the replica set or the job or deployment by looking at the pod template. But as soon as you start to think about how this would actually be implemented, it gets really quite complicated. So the first question is, how do you handle the delegation to the controllers that actually create the pods? And even if you come up with some system of looking at the pod template and comparing it to the actual pod, that starts to break down once you get into CRDs and third-party controllers. And what about mutations that happen on pod create? So you might check the policy on the pod template, but then the actual pod that gets created ends up looking different. And it also doesn't work for stateful policies like resource quota. Just to mention a few other problems with this problem. Composability and conflict resolution are something that we really need to think about when creating policies. So as soon as you add mutation into the policy, so for instance defaulting, what happens if two policies are trying to set two different default values? Which one do you select? Also, if you're mixing allow and deny policies, then the ordering matters. It doesn't matter if you just have static, non-mutating, deny-only policies because you can just check any of them in any order, and if any of them deny. Similar for if they're all allow. So this is how RBAC works and the authorizers. Another kind of area of inconsistency is, do we do domain-specific policies like scheduling policy or image policy versus resource-specific? We don't really have any resource-specific policies, but it has been pitched as like, what if we just had one pod restriction policy that applied to every field on the pod, and just anything you want to limit on the pod you can do. Other areas we discussed were default allow versus default deny. So what happens if you don't actually have any policy objects created? Default allow is nice because it's much easier to roll out. So you can say turn on the controller, and then as I add policies to different namespaces, I'm going to slowly scope down permissions. So I don't necessarily need to have a policy for everything in the cluster initially. On the other hand, default deny is more of a kind of fail closed approach and a little safer from that perspective. Similarly, for how we actually specify the policy definition itself, do we use whitelists or blacklists? What is the kind of matching pattern within the policy? We already talked about mutations, and then the last one is kind of namespace versus cluster level scoping. So for instance, in RBAC, we have both cluster and namespace roles. Pod security policies are cluster level objects. We've talked about a bunch that were namespace level, and so kind of figuring out what the right level is here. Question? Sorry, so if I understood the question correctly, you're saying, is default allow really less secure than... Only legally less secure? Or you meant only the way of speaking, actually usually sort of yeah, so the question is about default allow and what are the kind of implications of that. The risk of default allow is, suppose you have a policy that is preventing some sort of dangerous operation, and maybe you missed, maybe you had a namespace selector on it that said apply to all these pods, and you missed a namespace, right? And so now that namespace didn't have any policy applied to it, and suddenly you have the hole. Or maybe you delete a policy thinking that it's not used and realized that, oh wait, this was the last one that was actually limiting this one capability, and now suddenly you've, again, opened up a hole. Yeah, yeah. All right, with that, I think I'll hand it off to Jordan.
So I'm Jordan Liggitt. I work in the SIG Auth area for a while. Just to be clear, we're putting the links to the issues here. We would like more people to be thinking about these things and kind of participating in the conversations about these. These lists of problems are not just intended to paralyze us and never let us move forward, but we do want to kind of think deeply about the implications of these things before we set a direction and make sure that the incremental things we do don't shoot us in the foot long term. So I'm going to talk about how API servers authenticate to webhooks. So as extension mechanisms have been added, it's kind of a webhook all the things approach. So initially we had admission webhooks. In the current release, we have the ability to have conversion webhooks for custom resources and audit webhooks for sending audit events out to external sources. And so you can have this model where the API server is sending data out to some webhook, and then in some cases, like in mutating admission, getting data back, or in conversion, getting data back from the webhook. So you might be asking, why does the API server need to authenticate to a webhook? And so there are a few reasons. Webhooks that accept data need to know that the data they're being given is trustworthy. So if an audit webhook is going to be logging, like Jordan Liggitt tried to access this secret, I really want to only get that audit event logged if I actually tried to do that. I don't want someone to be able to spoof that and like trigger responses. Also, admission webhooks that take external actions, something that might be recording quota or recording things in an external system, you don't want to be able to trigger that except if that action actually happened. And then on the flip side, webhooks that return data, like a mutating webhook, we only want to return data to the systems that should have access to it. So if I create a deployment and one of the things that gets injected is like a sidecar container with some information based on an external system, we don't want to give that information back to just anyone. And then finally, just from an availability perspective, we only want to do expensive work if the person asking us to do it is the right person. So the simple approach is to just add in credentials or a credential reference into the webhook config. So when you say, I want to call out to this webhook, also like point to this secret and have the API server like read a credential from the secret and attach it to the webhook request. And that can work in some cases, but it makes a couple of assumptions. The first problem with that approach is that you can't distinguish between API servers. So if you have multiple API servers and all of them are making audit calls or webhook calls and they're just reading this shared credential, you don't have the ability to distinguish between them. And then the second problem is that the Kube API server is not the only one making calls to these webhooks. So if you have other aggregated add-on servers, you can't assume that they should all have access to this shared credential. So if you kind of look at the problem space, you have, on one dimension, you have whether uniform identity is okay or whether you want per caller identity. So there are cases where you're going to want uniform identity. If you're calling out to an external service and it's maybe just a crash logger and all you have is an API key and you don't care, you want all your servers to call out to this crash logger with the same key. Maybe that's fine for you, but we need to preserve the ability to have per caller identity. And in the other dimension, you have kind of how aware of Kubernetes is this webhook. If it's an external crash logger, it might not know anything about Kubernetes, and it just wants a particular credential. But on the other hand, you might have a webhook that was built to interoperate with the Kubernetes ecosystem, and so it's aware of like Kubernetes tokens and can do token review type requests. So if uniform identity is acceptable, then maybe the shared credential reference could work. And so we're considering having that as an option, not the only option, but an option for the various webhook configurations that you could say, when you call this webhook, use this credential. And if uniform identity is acceptable, that could be a possibility. That's something we're considering. If you're calling out to Kubernetes-aware webhooks, then the work that we're doing now to have these service account tokens that can be generated on demand and made very audience-specific could be a solution. So having an option on the webhook configurations to say, when you call me, do so with a service account token scoped to this webhook. And then all those various API servers could request that token as they were building requests to each webhook. That's a possibility as well. And then this is where we're kind of scratching our head right now. This is the fourth quadrant, and maybe important, maybe not. We could probably do work to make the first ones better and possibly defer working on this fourth. But that is that's the problem and kind of the ways we're thinking about it and the use cases we're trying to preserve. So, Mike, next up.
I'm going to do a quick summary of the current state of the Certificates API. So the Certificates API has been around since, I believe, 1.4 was introduced as alpha, beta by 1.6. That was almost 2 years ago at this point, and it still hasn't made it to GA. So we have some fundamental issues with the API. We're debating whether they need to be addressed before we bring the API to GA. We know a lot of users would like to see this API become a GA API. and where it hasn't had an advocate to see it through the process. So to highlight some of the issues, we have some structural changes that we would like to make to the API. If you're familiar with the flow, which was covered yesterday in the workload identity talk that I gave, the approver is responsible for approving certificates, however, or CSRs. However, the approver cannot modify CSRs, and that's because we take a lot of information encoded in the actual ASN1 CSR object, which is mutable after its creation. So that causes situations where maybe you have an init container that wants to request a serving certificate for itself and all the services that it backs. However, in order for that init container to discover generically the services that, that the pod backs, it has to have broad read permission on the API. So some of these problems could be addressed by migrating some of those fields, usages, and extensions out of the actual ASN1 body and into the CSR API object. We also have a very common feature request, which is to allow multiple CAs to sign certificates for this API and have requesters select CSR from a certificate from a specific hierarchy. And the way that the final bullet, the way that the API is today, there's not really a great guarantee that an operator can have around what actually comes out of this API. So we would like to improve the visibility into the certificate stream that is coming out of this API. And some of these bullets are probably going to be solved after GA, some before, but we're looking for people to work on any of these items. I think that's everything.
So that is a whirlwind tour through some of the top of mind. Yes.
About certificates, I had the impression that the API server and other components like Kubernetes, etc., did not support revocation yet. Is that the correct impression or not? And are there plans to address that within the scope of that, or is that a different scope?
Revocation is somewhat independent of the certificates API,
okay.
Just like certificate rotation is client-side behavior, and it's not part of the certificates API.
Okay.
We have no plans, although there have been proposals to support revocation. I think in general for cluster scoped certificates coming out of the cluster root CA, it's best to implement automation and very fast rotation. Even like CRL-based revocation, those if you have a CRL that's valid for a day, why not just issue a certificate for a day and avoid the problem of revocation, which is actually fairly complex and is not perfect in itself. However, if somebody wants to come and implement revocation and it makes a lot of sense and solves use cases, we'd be happy to hear it out and help shepherd that through. But it is not in scope for the certificates API to GA migration.
And just a tiny follow-up: when you say like quick cycling, do you what would you consider as fast? Like, are we talking like hourly, maybe daily? It's just to get an idea.
So it's a balance between availability and security here.
Okay.
So an hour, you're taking a pretty hard dependency on the API being up. Usually, you can solve an outage of the API server within a day. A bad situation would be if your workloads began to unauthenticate because of some extended API outage. If CRLs are usually signed for 24 hours, if you sign certificates for 24 hours, I think that's a pretty good.
Thanks a lot.
Yeah.
So we did want to leave some time for questions about this or any of the topics we talked about. So yeah, raise your hand and we'll try to send a mic around. And
I had a question about the certificate validation. I mean, at least my impression was that it's based on the issuer of the certificate. Do you have plans to support like policy-based validation, like with namespace name constraints and things like that?
We support name constraints for server certificate validation. Our root CA in the cluster is not name constrained. It's a single root, and generally people don't deploy it with subordinate CAs that could be name constrained. It depends on how you want to use name constraints. I think the answer to that question depends a lot on what you're trying to do. Spiffy has some concept of name constraints and also signing policy. So you can actually do a pretty expressive delegation that isn't even allowed in TLS spec. So if you have advanced use cases, I would actually recommend that you look at that spec.
Okay. And I had one more question about the previous slide for the token request per caller. Is the model going to be similar to like Kerberos, where you get a service ticket and a TGT to authenticate to additional external services? Or
it's not a PKI flow, so the PKI aspects of Kerberos wouldn't apply as much. It's more of an audience-bound token. So at the point where the caller was going to make a call to a webhook, it would go obtain a token bound to that audience. So it is a forwardable credential, but because it's bound to the audience it's providing it to, that's not particularly concerning. Maybe it's philosophically similar to Kerberos, like you get a per call credential.
Does it happen at runtime?
Yeah, well, it could. So it could happen at runtime. It could happen in a pre-populated way, but because the tokens that token request produces are time limited, I would expect it to happen at runtime. And to be clear, much of this is speculative. These things could work and are kind of the direction we're leaning, but these are all forward-looking. The question was about, are there well-defined flows like OAuth? OAuth hasn't typically applied so much in server-to-server components, so we're trying to leverage the mechanisms that we have, that we know we have access to by virtue of running in the Kubernetes server.
On the last slide, you had a couple of points there about approval flow issues and guarantees and issued certificates. Could you talk a little bit, could you provide a little more detail about what issues you're seeing there?
Yeah, so currently, the entity requesting the certificate has to know everything about the certificate they want. So the primary use was for node bootstrapping, and so it said, I want a client certificate for this subject. In cases where it's like a pod that needs to serve a secure server, it knows that it wants a serving cert, and it knows its own pod name, but it doesn't necessarily know like all the services that route to it and all of the subject alternative names and UIDs and various things. So it can say, please give me a serving cert valid for me, but it doesn't really know or have access to all the other information it needs to populate all the requested subject alt names. And so having a phase where an approver could say, I see that you are this pod, and I see that you are allowed to have a serving cert. I, as this central approver, will now go look and see what services are routing to you or what namespaces are applicable and populate additional information that should be used by the signer as it's generating the certificate.
So this is mediating the signing request before it goes out to the issuer with additional attributes.
Right, so there's a request, and then there's an additional information and approval step, and then issuing.
The second question was on guarantees and certificates. What kind of guarantees are you looking for?
So what I would like is, so Jordan just described a class of certificates that you might want to provision through the CSR API, which are for serving certificates for workloads. And then we have our class of certificates that we provision to kubelets, which is client credentials for kubelets. And I would like to have very constrained profiles and that are use case motivated, rather than have a very generic API where you can have certificates of all shapes flowing out of this API. So I think it's more around creating structured profiles of what are produced, and then having very good logging of what actually makes it out of that certificate API.
So profile is registered by SO type so that you become a request for one. You use the right profile to issue a certificate for that resource.
Yeah, correct. Each certificate that comes out of this API conforms to a profile, and then you have an understanding of the motivation of why the certificate was provisioned.
Istio has its own mutual GIS, those kind of things. If Kubernetes can manage a certificate, why we cannot use that one just for basically using mutual GIS with Kubernetes without adding another layer?
So the question is not why are we using Istio? Why are we not using Istio for some of these flows?
No, I'm just saying why the Kubernetes itself cannot provide the mutual GIS directly.
Yes, so I think that the general philosophy that I've had is that we want to enable very featureful authentication systems to run on top of Kubernetes. So whatever we can do to secure our core infrastructure and allow people to build integrations is where we draw the line. And if somebody wants a fully featured system like Spire or Istio, we want to enable that use case on top of Kubernetes, but we don't want to be in the business of implementing like credential policy, all these different aspects of Istio that Istio provides. However, if somebody wants to implement mutual TLS using our hooks, that is much lighter weight than Istio itself, then we want to allow that as well.
I just want to make a comment. If you go to the previous slide, and if the mutual GIS is natively in Kubernetes, we can save some of the work here. And then you can still use in policy with mutual GIS, but that's a lot of simplicity on this,
Yeah.
API server versus Kubernetes webhook. Then
I think Tim actually talked about mutual TLS for service accounts in your earlier slide.
Yeah, that's what, when we were talking about client and server authentication. In most cases, we're using service accounts for client authentication,
but for server authentication, we're thinking about building some approver flows to approve like dual server and client TLS certificates for Kubernetes service accounts within the cluster. And that's the use case for that is mostly for securing core infrastructure components.
And would require changes to the way that those infrastructure components are making and receiving requests.
Yeah.
So it's not a general purpose solution for everything.
Yeah.
Question about on the quadrant slide, the like per what did you say? Okay, per caller identity. So like the token request, when you have like so you start having multiple tokens, and these are like signed created by the API server. Has there been discussion about the like scalability like around that and having potentially a lot more tokens than your standard service account tokens that are rotating?
We have started running scalability tests using some of the new token volumes. So those have made it into our large cluster tests and KubeMark tests, and haven't introduced too much of an issue. I have a couple ideas that might be controversial around I think if we do eventually implement some sort of key binding of the token, we can actually get rid of the audience field.
We have left. There you go.
Just around scalability, so like OpenShift runs some of the largest kube clusters in existence, and probably our biggest pain point is we store so many service accounts, and all their secrets. So we might gain some issues from having token request ephemeral tokens everywhere, but I guarantee you will save so much space in etcd. Your life will be so much better.
It's 11:25. Thank you for coming. We'll be around. Yeah,